In the last section, we looked at what is matter and why we want to study chemistry and what the chemistry is going to help us do. One of the terms which was used there was energy. Right? And energy is, simply put, is a very simple thing that if you want to do any kind of a work, right, even in loose sense, not if you want to define work in the physics sense, right, but if you want to do any kind of work, you need energy. So, for example, today is a sports day and you're going to participate in the race, right? And you have to run, let's say, 100 meters, right? You will require some energy within you, right? So, without that energy, you can't even do anything, right? So, the capacity to perform certain task or do work is what we call energy. In physics, uh, or in science, we define work slightly strictly, right? So, the work, we call it like force into displacement. Okay, but we will not go much into detail here in chemistry, but it is the if we have a box here and we have, let's say, apply a force of 10 newtons, right, and we are applying the force and moving the box by, let's say, 20 meters towards right. Okay, so how much work we have done? We simply multiply the force which is was getting applied on the box, which was 10 newton, and it moved by 20 meters. So this is 200. Okay, and the unit for this work is joules. Okay, or other unit could be Newton meter, but we are not much worried about that right now. So we can simply say, if you need to perform any work, you basically need something, and that is called energy. Okay, so energy is a capacity or let's say ability to do a work, right? We can have alternate definition, and we can also define energy as a capacity to transfer heat, right? So heat is also a form of energy. We'll look into that. But for now, we just take our first line of definition. The capacity to do work is called energy. And basically, the energy comes or falls into two distinct types, if you like to say, right? The first is what we call kinetic energy. Kinetic energy, why? So if the object is in motion, right? If something is moving with a particular speed or a velocity, we call that it has some energy. And how do we know that? It's very simple. Suppose we have a table here, right? And I have placed a ball here, and then I have another ball over here. Okay, and I somehow want to knock this ball off. Okay, so how do I do that? What I'm going to do, I'll stand over here. I'm going to push this ball with certain force, and as a result, I will perform some work on the ball. Okay, once I push the ball for certain time, the ball starts to move, and it's going to move, and I'm going to hit the second ball over here. Right, when the first ball is going to hit the second ball here, you can guess what will happen. The second ball will also start to move, and basically it will get knocked out the table. Right, now what has happened? Whatever work I have done actually got stored in form of energy, and then carried away all the way to ball 2, and then transferred back to the ball number 2. Okay, so anything and any object which is moving actually stores the work, or we call it energy as well. Okay, stores the work. Okay, and any moving object, we say that it has some energy, right, because it can perform work, right, and that is what we call the kinetic energy. It's a very easy formula to calculate how much energy a particular object has. That is half into m, which is the mass, and v is the speed at which it is moving. Right, so any moving ball has kinetic energy. Moving car has a kinetic energy. Flowing water, because it is also moving, has a kinetic energy. Any boulder rolling down the hill has a kinetic energy. So anything which is actually moving has a kinetic energy, and we can simply calculate it using a very simple formula, half mv square. But we'll look into all this topic when we look at this from the angle of physics, right? But for now, we say that anything which has a capacity to do work has an energy, and we call that energy. And the first form of the energy is the kinetic energy. And kinetic energy is something when an object is in motion, by virtue of its motion, basically it has some energy, and we call that kinetic energy. Right? Now we look at another kind of energy which is called potential energy. Usually, this is because of your position. and it is sort of a stored energy, right? So the object could have like if I hold a ball over here with my hand, right? So I'm holding the ball over here, and it is higher from the ground. Okay, if I release the ball, you will find that the ball will start moving downward and come down here and basically strike the floor, right? So because of its position, it has some energy here, right? Because of its position, this kind of energy, which is stored in the ball itself because of its position, is also another kind of energy, and there are different kinds of energy, right? Such as chemical energy, right? So the coal has some energy stored into it, which we can take out by burning it. The gasoline or petrol has some energy which we can take out by burning it into the car, right? The food which we eat, it has certain kind of energy in form of chemical energy. When we eat, it gets processed within ourselves to provide the necessary energy for us to perform any work, right? So there are different kinds of energy, and fundamentally there are two different kinds: the kinetic and potential energy. Okay. The amazing thing is that we can basically convert the potential energy to kinetic energy, and also kinetic energy back to potential energy. Okay, so energy can be transformed from one type to another, right? So the left hand side, we can say, if we have to perform some work, we want to eat the sandwich. Okay, and the sandwich has some chemical energy which will finally transform, and then we can run using that energy, which will convert into kinetic energy, right? If we have some fuel, basically, or petrol, right, we can put it inside the car, and then it will convert into kinetic energy when we run our car. Okay, so basically we can convert back from potential energy to kinetic energy, and then from kinetic energy to potential energy, right? One of the example of back conversion will be, for example, the ball which is up in the air, right? You know that it can fall down, right? It can perform some work, and basically it has some potential energy, right? And that potential energy keeps on converting into the kinetic energy, and the speed of the ball keeps on increasing as it falls down, right? Similarly, I can throw a ball from here which has a kinetic energy, right? We keep on going up, up, and it will stop at a particular moment when all my kinetic energy actually got converted into potential energy. And then again, if there's no one to hold it, basically it will come back down and basically again convert the kinetic energy back into the potential energy back into the kinetic energy, right? So we can do this transformation from kinetic to potential, right? Pretty easily. So kinetic to potential, kinetic energy to potential energy, and we can do back and forth transformation of this energy of two different kinds, right? But when we look at the chemical processes, most of it is in form of heat, right? So sometimes we need to provide heat as an energy to perform certain kind of chemical reactions. We talked about in chemistry, so there's a matter and there's a properties of matter, and then we do transformation of those properties, right? So how do we do that transformation? Usually by providing heat, and basically, the energy flow in form of heat is what we are interested in, right? So that you can burn something up, or if you are in the sun, you can feel the heat basically hitting you from the sun, and basically your temperature going up, right? So the heat energy could be either taken away from the object, right? Or we need to provide heat into the object, right? So there are two kinds of different processes which can happen in terms of energy when we want to think about, right? One is called exothermic process, right? So whenever some transformation happens, the chemical transformation happens, basically the heat is released from the system, right? So for example, easy one will be the chemical transformation of wood by burning it to ash, for example, right? So when you will burn the wood, basically you will see that the heat is coming out, right? The chemical transformation of petrol in the car, right? By burning it, we'll see that some heat is generated and heat is given out. And some of the neutralization reactions also is the case when the heat energy is released, right? From the chemical reaction, we call it exothermic, right? So very simple way we can understand: when the heat is coming out during the chemical reaction, we call it exothermic process. And when we need to provide heat to make the reaction go, we call it endothermic, right? Or energy is absorbed from the surrounding. It is called endothermic. So one obvious example is if you want to melt the ice, we need to provide heat to it for it to convert from ice to water, right? If you want to convert the water to steam, we need to again provide some heat into it for it to convert into steam, right? So those kind of processes or chemical processes, now strictly we will say chemical processes because we are studying those changes of matter, is basically when we need to provide heat, right, from outside to for the chemical process to take place. We call those kind of reactions as endothermic. And when the heat naturally comes out of a chemical process, we call them exothermic.